Welcome back. We are talking about the uh, second phase of pen testing, that is scanning phase, that is port scanning. And that in previous session we have seen the different services provided by the different layers of your TCP/IP model and the port numbers which are assigned to them. So before getting to the actual scanning process, one should understand the network security infrastructure, how a basic some of the organizations they follow the security architecture. So let us first discuss this and then get into the details. Like, as we know that there are the perimeter devices or end devices we call, and intermediate devices. So the pen device perimeter devices are the end devices like your desktop computers, your IP phone, laptops, wireless tabs, your the printers are telepresent endpoints, servers, routers, and other equipments like switches, your firewall appliances, multi-layer switches. These are all comes under the category of your perimeter devices. So where we call these end devices, these end devices are connected to the one of these intermediate devices, and these intermediary devices are connected to the internet. So these perimeter devices, these devices sit at the outer edge of a protected network. So these devices serves as an intermediary between your protected internal resources and external networks like the internet. So we often begin by scanning these perimeter devices to look for weaknesses or vulnerabilities that will allow us to gain entry into the network. So let us see the physical topology of this network security infrastructure. We'll just check this. Yeah. So this is the diagram which shows the physical location of your intermediary devices like your routers and switches. See, there are different blocks are there. So in the server room, which is at the room location 2158, there are various servers are there, like web server, email server, file servers. Okay, so they are physically located in the server room at the cell 1 rock 2, in cell 2 rock 2. Email server is there in cell 3 rock 2 5. The file server is there, and they are connected with the internal switch, that switch 1, and switch 1 is connected to your router 1, and router 1 is connected to the internet. Okay, so this is one block, whereas in other side some computers which are physically located in some classrooms like 2125, 2126, 2127. So these end devices, they are connected to the internal switches like S3, S4, and S5, and they connected to R1 router, and R1 router is connected to the internet, right? And similarly, some office devices like printers and any presentation end devices, which are connected to your switch 2, and they are connected to your R3. So three different blocks are connected to a router, where we call this router is a the what you call the outer edge of this protected network from this internet. If this connection is disconnected, this network is isolated and they are fully protected, we can say. If they are connected to internet, then there is a chance of, while communicating with each other, the information may steal by some of the attackers or the pen testers also. So it's logical. So how this physical network security infrastructure is looks like in logical way means we assign the every device in the network. It may be end device or it may be intermediary device. They are identified with the internet protocol addresses, that IP addresses. So the network which is located in the server room is at the IP address 192.168.10.0. So the first three bytes are used to identify the network location we call network address, and last byte is used for your host address purpose. So this host address identifies whether it is a web server, email server, or your file server. And similarly, the classrooms are identified with their network addresses. The first three bytes, like the first computer is located at 192.168.100, second one is located at 101, third one is located at 102, and here these printers are located at 192.168.1. So this is the way and how these devices are connected to the switch by using the fast ethernet cable. So here we are going to check whether what are these ports, whether these ports are open or closed. And similarly, every device is having are identified with network address port or network address card port, NIC card, are the port numbers that we can say. So this is the logical topology. So from here, you can see that it is important to mention that there is a difference in the severity of various vulnerabilities. Some vulnerabilities may present little opportunity for an attacker, whereas others will allow you to completely take over and control a machine with a single click of a button, right? So I have had several clients asking me to attempt to gain access to some sensitive servers on the internal network, like it may be some database servers or any server. So in this infrastructure, you can see that it is fully networked with the perimeters, which includes the end devices, like end device one, let us say host one. Let me just change this color. uh, yeah. So let us assume this is the host 1, host 2, host 3, host 4, host 5, and so and so. And there is a internal switch here, network switch, and which is connected to the router is connected to the firewall, and firewall is connected to internet, and through internet anyone can connect. So this is a local area network. See, local network, this is LAN, local area network, right? So in this example, we can see it is obvious in this case that the final target is not directly accessible via the internet. If you try to access from your remote worker to your host one, you first need to connect, go through internet and pass through the firewalls, then pass through the router, then pass through the demilitarized zone, and then pass through the network switch, and then connect to your host one. So in this scenario, if you see um, that whether we are going after some uh, I mean the super secret internal machine, or simply attempting to gain access to a network. So we usually begin by scanning the perimeter devices, right? So the reason for this is simple. We start at the perimeter because most of the information we have from your reconnaissance phase belongs to a perimeter device. So also, with many of today's technologies and architectures, it is not always possible to reach directly into a network. So as a result, we often employ a hacking methodology where we chain a series of machines together in order to reach our final target. So first we conquer a perimeter device, and then we move to an internal machine. So in this case, what is happening? Suppose here is the target. Let me just change the color. Yeah. So suppose here is the target for us, the target machine. Okay. So target machine is connected to the switch. Switch is connected to a router. Router is connected to internet, and through internet the pen tester is connected, suppose. So in this case, what happens, the process of compromising the router, and then using that router as a stepping stone to attack another machine, like switch in this case, is called, we call this as your pivoting. Pivoting. So this pivoting is most often used when the target machine is attached to a network but not directly reachable from our current location. So hackers and pen testers may have to pivot several times before having direct access to the original target, right? So the perimeter devices are computers, as we said. We often begin by scanning the perimeter device to look for the weaknesses. Is there any weaknesses at the router level? Is there any weaknesses at switch and your target? So that weaknesses and vulnerabilities at this stage, that will allow us to gain entry into the network. So once we have successfully gained access, the scanning process can be repeated from the newly owned machine in order to find additional targets. From, suppose if we get the access of your h1, then from there we try to gain access to your h2, h3, h4 and h5 in this case, right? So this cyclical process allows us to create a very detailed internal network map and discover the critical infrastructure hiding behind the process, right? So how do we do this then? So this is the fully parametered the network with the infrastructure. Okay. So in this case, our first step is uh, how to, whether this the host one is reachable or not. The host one, or this host one is reachable or not. So what we do, there are different ways of doing this one, whether host one is reachable or not. So what are the different ways? One way is we try to do the ping operation. Pinging the target, because in the first phase, in the reconnaissance phase, we know the ip address of this target which we collected. So ping is a special type of network packet. We call this internet control message packet, that icmp packet. icmp packet, right? Internet control message packet. So this is a service provided by your internet protocol, okay, that ICMP packet. So the pings work by sending a particular type of network traffic uh, called the ICMP Echo request packet to a specific interface on a computer. Specific interface on a computer. So we call these are the interface where they are connected, the different interfaces. So if the device which is suppose connected, the attached network card, suppose the that device, if the device that received the ping packet is turned on and not restricted from responding, the receiving machine will respond back to the originating machine with an echo reply packet. So aside from telling us that a host is live and accepting the traffic. That is live and accepting the traffic. So we'll see this. So if the so aside from telling us that a host is live and accepting the traffic, pings provide other valuable information, including the total time it took for the packet to travel to the target and return. So pings also report traffic losses that can be used to gauge the reliability of a network connection, right? So we'll see this with an example. Let me just quickly get into that. Yeah. So if we run a command like in the ping in the command prompt of your Kali Linux machine, then you will find this ping target that it will give this command that ping and target IP address which we have collected during the first phase of our uh, penetration test. So by just sending the ping packet or ping the domain name or its IP address, domain name or its IP address. So from this command, you will it will tell the system that uh, try to reach to the destination whether it is live or not. So here you can replace this target IP with the in this command the target IP can be replaced with the domain name or the target's IP address or the host name of the machine you are trying to reach, right? So in this figure you can see that from the command prompt we have given that ping google.com. Okay. uh, Let me just get into uh, the machine so that practically we can check it out. Let me share the screen. Kali Linux. Okay. And yeah, let me close this. Okay, so here we can give the IP address like ping, and let me give the google.com and just press enter. It will try to connect with the Google. Okay, let me just check it out whether it is yes. So here you can let us analyze this ping packet. Let me hold this control C. So from here you can see you can analyze that. In the first one we have just given the command the ping google.com. So from ping google.com, either you can give the domain name or the IP address which we have get here is the response from the IP address that 142.250.190. So this is the IP address where you are getting, or you can give the ping command like ping. Instead of domain name you may give that 142.250.191 dot oh sorry yeah, 250 dot 191 dot 110. It will also try to reach that machine. Okay, so you can see the difference here. Okay, when you are giving the IP address, it is and when you are giving the domain name address, you find some difference over here. So we'll discuss first this. Okay. So from these packets, when the you are trying to, from our Kali Linux, when we are trying to send a ICMP packet, here you can find the ICMP packet is internet control message packet for the echo request purpose, whether the device is reachable or not. So when we are sending this packet, or yeah, so in this, we just focus our attention on the third line that starts with the 64 bytes from. So this line is telling us that our ICMP echo request packet successfully reached the target host, and that the host successfully sent a reply packet back to our machine. So the 64 bytes indicates the size of the response packet, and the from you're having the from ORD 38 S380. So the next field of your line 3 here, which specifies which host name and the IP address responded to our google.com. So the ICMP sequence here, the sequence of your packets, uh, this designates the packet order, and where time to leave the TTL, suppose 111, is the time to live value. So this is used to determine the maximum number of hops the packet will take before automatically expiring. And we lastly we have the time is equal to 41.8 milliseconds. So this is telling you how long the entire trip took for the packets to travel to and from the target. So after stopping the ping command, we will see this. When we stop this ping command, we will see here the observation from here is, uh, and when you stop this, you will be provided with an output of statistics including the number of packets transmitted, packet loss, and a series of time based stats. So if the target host is down, suppose offline, or blocking this internet control message packets, then we will see 100% packet loss, or a destination host is unreachable message, that depending on which operating systems you are using. But sometimes in sporadic network connections, you may see multiple request timeout and a few with a response. So this is typically because of a poor connection to an environment, or the receiving system is experience the network issues. So here you can see that when we are trying to ping with the google.com, then we our system send 18 packets are transmitted to the destination, that is the target, google.com. And out of 18, 16 packets were received by the target, and for those 16 packets the response came here, and the number of packets, around 2 packets are lost. So around 11.111% of packets are lost. Okay. And the total time taken of the travel time for this particular 16 packets is 17035. Right. So now that you have a basic understanding of how the ping command works, so let us see how we leverage this tool as a hacker later. But suppose if you know the IP address of your target, by just pinging that IP address, IP address, you will get from which target you are getting the reply for this particular echo packet, the ICMP packet request. So that is 64 bytes the packet size coming from the response is coming from this target IP address, and the ICMP packets sequence. You can see that 1, 2, 3, 4, because there are 8 packets are transmitted and 8 packets are received. So now see the difference. When you are giving the domain name system here, then some packets may be lost. But if you know the IP address of the target, then it will, if it is up, if it is not down, the target is not down, then all the transmitted packets are received by your target, and there is a zero packet loss is there. There is a zero packet loss is there. Okay, so similarly, we will you can try for other systems also. Like, let me just try to ping SREC warangal.ac.n, and when we try to ping this, you can see it is also reachable. So you are getting the response for it. Let me do the control C, so that it can come out of this particular ping option. So now you can see that how many 9 packets are transmitted. Out of 9, 8 packets are received, 1 packet is lost. So now let me just ping to the same the target. Instead of giving the domain name, if I know that IP address which is pinging here is suppose 103.67.239.199, and just enter and just check it out. We have sent 4 packets, and all the 4 packets are received now, right? So this is just to check it out, the first phase of your the scanning port, as we discussed in previous lecture, that the first phase of your scanning phase is whether the target is live or not. To check it out, we use the ping command by sending the ICMP echo packet. So now that you have a basic understanding, right? So because we know that pings can be useful in determining if a host is live or not, so we can use the ping tool as a host discovery service. So unfortunately, the manually pinging every potential machine on even a small network would be highly inefficient. So, fortunately for us, there are several tools that allow us to conduct ping sweeps. A ping sweep is a series of pings that are automatically sent to a range of IP addresses rather than rather than individually entering each target's address. Like that, we are trying to reach to this target like 103.67.239.199. Instead of that, if we wants to reach to a target of the a range of your targets or individuals, then we can use the simplest way to run a ping sweep is with the tool we call the fping. We call the fping. So this fping is built into the Kali and is run from the terminal, as you know. So the tool can also be downloaded for Windows. The easiest way to run fping is to open, we'll just open this terminal and we just type that fping, and then give the command that -a. We will discuss about this switch -g. Okay, then the target IP address, that 103.67.239, and we start scanning. I mean, they start to reach a range of individuals, like right from 1 to your all the hosts which are there in that particular network address. So the first 3 bytes are your network address, and the last byte is your host address. So number of hosts starts from 1 to, that is the default gateway, to the last host in that particular network is 254, host number 254. Then we'll try to collect all these will try to reach to all these hosts, and their IP addresses will be written into this particular text file. So here minus a switch is used to show only the live host. We are interested only the target host which are up, which are not down. So it minus a shows that the live hosts only. Okay, and this makes our final report much cleaner and easier to read, that who all are out of 254 hosts, how many hosts are live and how many hosts are down. Next switch is we are using the minus G switch. So this minus G switch is used to specify the range of your IP addresses we want to sweep. So here our range is from 1 to 254 is the range on network address 103.67.239. So you need to enter both the beginning and ending of your IP addresses. So in this, we scanned all the IP addresses from your 1 to 254, and then we use this the greater than symbol here. This character is used to pipe the output to a file, and the file here is our host.txt file. So this is used to specify the name of the file our result will be saved to. So to view the and we just by just pressing enter, it will try to collect all the hosts on that particular network, all the live hosts on that particular network. So it start collecting it. Once it is collected, then let us try to check it out. Here you can find the ICMP host. Some hosts are unreachable, and unreachable from this particular source to the destination is this. These are the some of the destinations, right? So to check it out whether who all are the live on this particular network 103.60 on this particular network address. Okay, so for that, first let us check it out. Let me go ls, and the here the host file is created. Let me use the command cat host txt, the cat host, okay, uh, txt, to check it out who all are open, I mean the live in that particular host. So you can see that most of the devices are reachable. So first you're finding the 103.67.239.1. It is the router, the first device in that network, that we call that the outer edge of perimeter. We call the edge router. So from that edge router, the first the host from starts from 2 160 103.67.239.2 to 49. Those hosts are down now. They may be set down, and the host from 50 to 51 52 is also down. So these are all the hosts which are now currently active there. They are currently active there. So to check it out this, we use which are in our host, we use the command the cat and host file. So to know more about the fping, for ping sweeping, we may use the command man command and fping. By issuing this, you will get all the information. This fping is a program like your ping, which uses the internet control message protocol, that is the echo request to determine if the target host is live or not. So fping differs from ping in connecting that. If you are using ping means you are going to connect check whether the host is live or not, whether the target is live or not individually. If you use the fping, all the live host list will be given to us. So for that, it use the option you may use that if you use -4, then it will restrict the name resolution protocol, that instead of sending the IPv4, you can use -4 as -4 for IPv4, -6 for IPv6, and -a, as we said, for whether the hosts are alive or not. Capital -a, if we use that one, capital -a, so that displays the targets by addresses rather than the DNS names. So this -a will be combined with -d, uh, that output will be both the IP and the host names. So you can see the -b is used for how many bytes are there, that we have seen that the ICMP packet byte is 64 bytes in our example. So you may restrict this with the by just giving -b, that how many bytes can be sent. And so you can find a lot of the switches here to find out the lookup addresses, to check for the I mean the pre-target statistics, and so on. So with this, let me just use the quit command from here. And so this is the basic of your ping and ping swapping. So in the next lecture, we'll try to discuss the port scanning then. We'll try to discuss the port scanning. Thank you.